Welcome to qnawire.
Hi, in the given problem, the magnetic field is getting into the plane of paper perpendicularly, and there is a straight conductor AB. This is the straight conductor AB, which is moving in the given direction like this with a speed v. The length of the conductor has been given as 30 centimeter, or we can say this is 0.30 meter. The magnetic field getting into the plane of paper is 0.450 Tesla. The speed with which it is moving in the direction as shown is 5.00 meter per second. The direction of this speed of the straight conductor is perpendicular to the magnetic field, means this conductor is cutting the magnetic field lines perpendicularly. So in the first part of the problem, we have to find the magnitude of EMF induced across this conductor. So that will be given by the product of magnetic field B, speed V, and the length L. And when we put these values for the magnetic field, this is 0.450 Tesla. For the speed, this is 5 meter per second, and for the length, this is 0.3 meter. So all these things multiplied to give us 0.675 volt. This is the potential difference or EMF induced across the ends of this rod. This is the answer for the first part. Now, in the second part of the problem, we have to find which end of this rod, A or B, will be at a higher potential. So, when we apply Fleming's right hand rule, we get to know the direction of current induced will be from A to B. The direction of current induced is from A to B. And as we know, in the motional EMF, when a motional EMF is induced across a conductor, the current always runs from the low potential end to the high potential end. Low potential end to high potential end. So it is obvious that end B is at higher potential. So this is the answer for the second part of the problem. Now, in the third part of the problem, we have to find the electric field across the ends of this conductor, and that will be given as the potential gradient, means the gradient of this EMF with respect to length. So this is 0.675 volt divided by the length of the conductor, which is 0.3 meter. Hence, it comes out to be 2.25 volt per meter. This is the answer for the third part of the problem. Now, for the fourth part of the problem, we have to find the end. Which end of the conductor will be having excess of positive charge? So obviously, as end B was at higher potential, as B end is at higher potential, so B end will be having excess of positive charge as well. Now, finally, in the last part of the problem, they are saying what will be the EMF induced, the potential difference induced across the rod if it moves parallel to AB. But we know in the expression for the induced EMF, induced potential difference, the three terms B and V and L, all these three should be perpendicular to each other. So if the rod starts moving parallel to AB, then the speed, the velocity vector will become parallel to length vector. So the EMF induced will become 0. And in the second case, we are saying the rod is moving directly out of the page. So if the rod starts moving directly out of the page, it becomes anti-parallel to magnetic field lines. Means again, the velocity vector will become parallel to or anti-parallel to this magnetic field. Means it will not be perpendicular to the magnetic field. So again, the EMF induced will become 0. Thank you.